So, what we call a stem and a leaf plot, it's going to look like this. And like lots of different graphs, we try to title it so that we have an idea of what the numbers mean. So this says these are race running times in seconds. You have two parts to the graph. You have what's called the stem, and you see these values 12, 13, 14, all the way down to 18. And then over on this side, these would be the leaves, or the leaf. Okay, and over here, notice that these values are a little bit spaced apart because they represent different values. Okay, you're also going to see a key that goes with this. So it might say 12 with the line 2. So the 12 is the stem. The first value is your stem. The line that you see is the separation. And then they're picking out one of the leaves. And they're going to say, well, that represents the value 12.2. So now we kind of know that these values that we're seeing are decimals. So this represents 12.2 seconds in time. This would represent 12.6 seconds in time. This would be 13.0. This would be 13.2. This would be 13.5. So each one of these leaves represents a different piece of data. Notice that these are in order numerically. Okay, so 2 and then 6. 0, 2, and then 5. These leaves are listed in order. These leaves are listed in order. Each line, we have listed them in order numerically. No commas. Okay, we don't put commas between the times or anything. We just leave a little bit more space than what we normally would if we were writing a value together. All stem and leaf plots should have a key to them so that you understand what the numbers are representing. How to read the numbers. In this case, they're decimals. I wouldn't know that without the key. The other thing I want to tell you about leaves is they're always singles. Okay, so the stem, these are 2-digit stems. We could have 3-digit stems. We could have 4-digit stems. These stems can get bigger, but the leaf is always a single value. So when you're looking at a set of data and you're trying to decide what portion of the number is going to be the stem and what portion is going to be the leaf is always the single value. There's things that I can read, things that they might ask you for, like they asked for, in your last worksheet, they asked you for the range. It's not difficult to come up with the range from a stem and leaf plot. Okay, what is the smallest value or the lowest value that's in this example? The 12.2. And what's the highest value? Where would that be found?
18.3.
Okay, you go down to 18 and it'd be 18.3. So if I subtracted those two values, just like I did before, what did I get?
6.1.
Okay, so my range would be 6.1. Now, could I find a mean value from this? I could. It may take a little bit of time. You'd have to take 12.2 and add it to 12.6 and add it to 13.0 and add it to 13.2 and add it to 13.5.
And then be annoying.
And then, would you know how many pieces of data are on here?
No.
How would you figure that out?
Counting them all.
By counting which side?
The leaves.
The leaves. You'd count the leaves to know how many to divide by. Okay, so you can still find the mean from a stem and leaf plot. And then the median. Where would the median be located on this? Kind of in the middle, right? You would have to, okay, I've got 2 that are low here and 2 that are high. They're going to cancel each other out. I got 3 that are low and I got 3 that are high. They're going to cancel each other out. And you can work your way in until you find the middle value somewhere in here. So you can also find the median from a stem and leaf plot. This is one way to organize it. Okay, what it might tell you is where is the bulk of your times? Where are the majority of people running? 15, 16 seconds maybe is what you could see from that. There's different times where a stem and leaf plot would be a better choice of graph than some other things. But you can get some things off of this. Okay, so you're going to be making a stem and leaf plot. Now, what's a histogram?
Yes.
Okay, for a histogram, They're going to do prices of sandwiches.
Oh boy.
Okay, so I'm going to give you $4 for a data piece. $4. You think that's expensive? $4.25.
Is like
$4.50. $4.75. $4.25. $5.95. Now we're getting into Chick-fil-A. $5.50.
We're getting to Chick-fil-A.
$5.50 and $5.75. So these are representing sandwich prices. We should always label our graphs. And when it comes to a histogram, you want to make a frequency table.
Is it not recording?
Probably stopped. You want to make a frequency table. So we've got to have an interval and we got to have a frequency. And you get to decide what the intervals are, but you have to be consistent in your interval. So when you look at your values, I've got to go from $4 all the way up to $5.95 is the largest. So that's approximately a $2 difference range, $2 range. So I want to break this up into different intervals. I don't want a ton of them. But what do you think we should divide the cost into? Maybe every 50 cents, maybe every dollar, maybe every quarter. What do you think you would do? 50 cents? Okay, so let's go from $4 to $4.50. That's an interval of values. That means my next interval would go from $4.51. Actually, I'm going to come back here. I'm going to say $4 to $4.49. And then I'm going to make my next interval $4.50. What would it go up to if the interval is consistent?
$4.49.
$4.99. Yep. So I'm going to put 49 cents in each interval. Otherwise, my numbers are going to get a little bit crazy. Then it would go to $5, and it would go up to $5.49. Sorry, $5.49. And then I would go from $5.50 to $5.99. And you just want to keep creating an interval, and they all have to be consistent. So they all have to have the same difference in each one. So every interval that I created contains 49 cents. I like doing it this way because you can see $4, then $4.50, then $5, then $5.50. Versus if I'd have gone from 4 to 4.50, then this would have been 4.51. I would have had to go on to 5.01, $5, and then I would have gone to 5.01. So you could do it that way, but I'm going to do it this way. So you create your interval, and you could be different from somebody else, but these are the intervals we created. Now you're going to go plug these pieces of data into your table. So there's a $4 sandwich that occurred in this interval. Here's another $4 sandwich, so that occurs in this interval. Here's $4.25. That occurs in this top interval. $4.50. That would be in the second interval. $4.75 would be in the second interval. $4.25, that's back in the first interval. $5.95, that'd be in my last interval. $5.50, that would be in my last interval. Another $5.50 and another $5.75. So I've got 4 sandwiches in the first interval, 2 sandwiches in the second interval, and I've got 4 sandwiches in the final interval. I didn't have anything here, but that's okay. Now, that's your frequency table. You got to build that. Now when you make your histogram. A histogram is just like a bar graph.
Oh boy.
Okay, you're going to put your frequency along the y-axis here. My frequencies went from 0 to 4. I'm just going to go 1, 2, 3, 4, 5. Your frequencies go along the vertical axis. And your intervals go along the x. Now this interval, I'm going to divide it up. I've got 4 different intervals, so I'm going to divide it into 4 pieces. Okay, that line is not the interval. This space is the interval. That's the interval from $4 to $4.49 is this first space. The second interval goes from $4.50 to $4.99. That's that space, not the line, not the mark, but the space. Then we got $5 to $5.49. And then we have $5.50 to $5.99. And you make bars. So that first interval had 4, goes up to 4. So it's going to be all the way, and you're going to shade this in. The second interval frequency was only up to 2. So you shade that bar in up to 2. Nothing in the third interval, so we leave it. Last interval, it goes up to 4, so we create a bar over here.
Yes,
And there's your histogram. Some things about your histogram is you should not leave spaces between the bars. So don't make a thin line and then a space and then a thin line. They should be next to each other. There should be nothing in between. Okay, this is blank because I can now visualize that that interval has nothing. No values fell in that interval. That's why there's a space there. Otherwise, they'd all be next to each other. Okay, but that's how